All human behavior, including language, is the working out of intentions, what our minds are directed towards.
The Interplanetary Podcast. The exploration of space for the benefit of all humankind. Your hosts in England and Sweden, Matthew, Russell and Linn Boldt-Christmas.
Oh, baby. Daniel L. Everett. Oh.
Thank you very much. Who is he?
I've got a little section which is called George's Crazy Space Section of the Month. It's a working title. I haven't quite found out what we're going to call it
Iteration
yet.
number 1.
He normally has something a little bit left of centre to talk about, and this time it's languages. Alien languages. Alien languages, because he had some interesting thoughts. But this guy, Daniel Everett, he lived with these people.
Mm-hmm.
It was very interesting what happened to him. He's kind of the man.
Fun fact about me is that actually one of my hobbies is languages and linguistics, which is so lame, but I think it's very fun, etymology and stuff like that. And my fun fact of the day is, this is because I'm Swedish, so I think this is interesting. Our close neighbor, Finnish, the language in Finland, is actually from a totally different root from all the other European languages. It's from the Uralic side, which means that all the other languages in Europe, the Indo-European languages, we actually have more in common with some of the Indian languages like Sanskrit than we do with our next door neighbor, Finnish.
George actually told me that, not during our little chat. He, like you, has got massively into linguistics.
Why didn't we talk?
I was going to say now I could have had a day off if I'd known this. You could have done this little section with him. Oh, that's a little bit annoying.
Next time, I'll just call him after hours.
We're going to talk about the black hole picture, aren't we?
Yeah,
we're going to do that.
Black hole picture.
I'll tell you what I haven't done on this podcast for a long time, and I mean a long time. I was looking back through it. I haven't talked about rockets for a long time, and I thought,
that old thing.
I know. Like, how do we get into space? All this space stuff is pretty meaningless, and unless we can actually get out there. And obviously, we've had some great successes with like the launch of the James Webb.
So we have
getting that to the exact spot, using the least amount of fuel possible, which was
such an emotional roller coaster.
And it's actually returning pictures now.
Yeah. I think it's almost done.
Yeah, like the pictures now are better than Spitzer, and it's not even commissioned yet. So yeah, that's super exciting. And I bet you're excited as well, because I didn't realise that a lot of the time on the telescope is already being allocated.
Yes. When James Webb was being sort of designed and going through the phases of figuring out what it was supposed to do as its main objective, exoplanets stuff was not as well established as it is today. But now it's a huge amount of the time on the telescope from this first round of telescope time that's been allocated is specifically for like exoplanet stuff. And I'm very excited because it's actually going to have some close collaboration with some of the ground-based telescopes that we're working with. So the thing is, that I'm sure we've spoken about on here before, is that, there's pros and cons of being a space-based telescope and a ground-based telescope. And if you're in space, then congratulations, you don't have a pesky atmosphere to deal with. Fantastic. But you are much, much smaller, specifically in the mirror size. Because space-based telescopes have much smaller mirror sizes, right? And the mirror sizes is the thing that decides how many photons you are actually able to collect. So if you're just looking at literally how much light are we getting, then big mirror, more light, smaller mirror, less light. And to be able to launch space telescopes, they obviously can't be as big as the Very Large Telescope. That thing is huge. So the James Webb Space Telescope is fantastic in many ways, but it's much, much smaller than the telescopes that we have on the ground. For example, the Very Large Telescope. So that one, while it has to deal with the atmosphere stuff and some things like that, it does have a bigger mirror size. And so there's pros and cons to these kinds of things. So we are very excited about having a lot of collaboration in the future. For example, the CRIRES Plus instrument on the Very Large Telescope covers a very similar wavelength band as the James Webb.
That's far infrared, isn't it?
Yeah, well, mid-infrared on James Webb, and
in other words,
infrared-y.
Heat. In other words,
yeah.
Heat, isn't it?
Yeah. And that's the thing. And especially if you're looking at planet atmospheres, then this is a really useful wavelength for looking at especially certain kinds of molecules like water and methane and carbon monoxide. So if we take the ground-based telescope with its big mirror, look at the same kind of targets with that as we do with the space-based telescope, which doesn't have the atmosphere to deal with, then you can sort of use them in parallel and you can cross compare and see what you're getting. And then you get perks of both.
Yeah, it's super exciting. I mean, and the same for the people that look at solar system objects as well, like turning it to Uranus and places like that, where it's
exactly.
like, oh yes, we're going to actually get a deep dive into Uranus.
Yeah. Yeah, I see where the gas giant. Wow, never heard that joke before.
No, but that's
no, but it's true. It's true.
There's all these really interesting new chemistry that they're and states of matter that might be the core of things like Uranus and Neptune. It's super exciting, that stuff.
It's amazing. I actually saw a headline today, and I just saw the headline, so I don't know more about it. But it was a paper that was talking about how apparently the color difference between Neptune and Uranus, I'll say,
bring back Uranus. That's what I'm saying.
Yeah. So the color difference between Neptune and Uranus comes to do with the hazy gas. Yeah. So you know what? I'm going to back out of this anecdote because
yeah, it's like having Jamie back on the show.
Yeah. But you know what? The thing about James Webb, I think, is very exciting. I mean, I can't talk that much about it because it's not my field, but the cosmology stuff that is hopefully going to be able to be done with it is really, really exciting.
Because Hubble's still going and they're complementary as well, aren't they? So that's
exactly.
I mean, it's basically an absolutely amazing time to be an astronomer.
Yeah.
Very jealous, Linn.
Well, you know what? This is, especially when I talk to like kids and in an outreach capacity, I think the best analogy with different telescopes and stuff like that is because they cover different wavelengths. I compare it to learning the different parts of a song. And if you want to learn how to perform a song or a piece of music, you have to both listen to everything individually. You have to listen to the piano isolated and the drums and the guitar and everything. And you learn those parts on their own. But then you bring them together to create the whole piece of music. And I think this is the same thing with the wavelengths. So you need to look at X-ray astronomy. You need to look at infrared astronomy. You need to look at all of these individually. But then when you know what's going on in those, you put them together to get like the full picture kind of thing. And this is exactly what we're doing with, say, Hubble and James Webb.
Yeah, and what's super exciting about it, and I always got worried about James Webb, and which is a little bit of my worry about the pictures of black holes, is that the picture of the black hole, let's face it, is pretty rubbish. Until you explain it, until you explain it,
sure.
It's obviously incredible. But to just someone that opens up the newspaper, it's like it's a blurry orange donut, right? Whereas pictures of things like the pillars of creation look beautiful, but what's amazing about James Webb is because it's narrow band, it's not just going to be narrow band in say 3 or 4 different emission lines, but in 7 or something like that. So the amount of detail that you'll be able to eke out with color mapping and the way that they're going to do it, I think we're going to get some very pretty pictures at some point.
I like pretty pictures. I mean, data is good, but I like pretty pictures.
Well, no, but there's something. I think there is data in pretty pictures, almost because it kind of reveals things that you can go, oh, that's interesting. And for outreach, let's face it, Hubble's couldn't have been better with those big coffee.
It's been very good PR.
Very good space PR.
Good marketing.
Yeah.
Absolutely.
Yeah. We managed to completely avoid talking about rockets. I only thought I'd talk about rockets because there's some interesting... I mean, it is a big year for rockets, this one. Or it seems to be shaking up that way. Because we've got Elon Musk who's completely dominating. Get this, 20 out of the 22 Falcon launches so far, and there'll probably be another one by the time this episode comes out, are reused. So that's just become the norm now. Like reusable rockets, that's the norm now. It's completely ruined the Russian market, which we'll get onto as well. Because I'd say I'm going to defend Elon Musk. A lot of people have been having a go at Elon Musk, but the one thing I'll say, in terms of space, without Elon Musk, there'd be no way to get to the International Space Station.
Yeah.
And there'd been and the Starlink internet seems to have been a pretty good thing in Ukraine. So good on him. Good on him for that. And
no comment. No comment.
No comment. But and then of course, we've the one that I'm really worried about is the ExoMars 2022. That's kind of that's been cancelled because of this Russian fiasco as well. So
space projects don't usually need an external excuse to be cancelled.
I mean, this thing has missed its launch window so many times.
Yeah.
It's gutting for all because of course that's built very near where I am right now.
Oh yeah,
so it must be very annoying for the people that.
Have you seen? Is it really like dead in the water? Not postponed. It's really cancelled.
Well, I mean, it's all integrated with Roscosmos's.
Right. Yes, of course.
The lander, the Kazachok lander. So if you don't have that, I guess it would. I don't know how much of a rebuild or a rethink that's going to take.
Yeah.
I mean, you'd hope that we want to get this rover onto Mars at some point, but maybe there's just not the money or the will to do it now.
No, and maybe I mean, because something we've talked about on this podcast before is the enormous timescales that space projects happen on. Like we're talking multi-decades sometimes. And so it might be a case of when you get towards the end of a project, you're kind of already using designs that are older. So maybe at this point they'll just go, you know what, let's just redo it, take what we've learned, and then start with a 2022 level of technology replan.
Yeah,
if they're going to do it, I wouldn't blame them. If it's now like looking down the barrel of another 5 years or something, then maybe they would just do something bigger and better.
Yeah.
But, so sad.
It is sad, but that's what happened to James Webb in actual fact, isn't it? And
exactly.
It's like James Webb went through various reiterations, and then you know that whole. It's very interesting reading the management of James Webb and all the lessons learned in terms of how to not have such a ridiculous over budget and overrun, etc., etc. Yeah. Of course, we got a whole heap of Maiden rocket launches.
Yes.
We've obviously just seen Starliner actually get to the International Space Station and back. So actually, maybe Elon Musk won't be the only person to be able to get to the International Space Station soon, which will be let's face it, that's a really, really good thing. But well, I mean, we've already seen like to only have one way to the International Space Station is clearly lunacy. Like that is like that's bad. That's bad.
I mean, what would have happened if the conflict that happening in Ukraine and Russia now? What if that had happened 10 years ago? You know,
or even 5 years ago?
Yeah, exactly.
Or 3 years ago, we would have been in serious. What are we going to do? Because it would suddenly be lots and lots of cancelled flights for people like Matthias Maurer and all that lot. So it would be annoying, wouldn't it? We might even have Artemis 1 launch this year, the SLS. That's got to be the launch of the year because that's got to be the one that's going to take your head off.
Yeah, metaphorically or.
Well, I mean, if you're near enough, probably actually. Well, definitely actually. I mean, if you were near enough, you would definitely die. It would definitely take your head off. So from sound alone. Yeah.
How long has that been planned?
Well, there's another one.
Another long term.
There's another one where it's still the jury's out about whether it will ever carry people.
Yeah.
You know, which is pretty frightening. Now, but the big one this week for me is Virgin UK. So you know the rocket, the Virgin Orbit that dangles from a 747. Well, a few years ago, I interviewed the boss of Spaceport Cornwall.
Oh, cool!
In Newquay, and they actually plan to do a launch in late August out of the UK from the Cornish runway, which will be the first orbital launch from Western Europe.
Wow. Jubilee, step down. Time for another kind of national pride. The only thing British first.
Well, you see, I think that if that doesn't happen, then you've got these vertical launch systems. So there's two. There's Saxavord, which is well on its way to being able to launch some rockets, but they may not be British ones. They may be like American ones. Hilm Impulse, Astra apparently, Skyrora are a Scottish rocket company.
Yeah, I know of them. Yeah,
they might be the first vertical launch. In Western Europe and from this UK spaceport. But hot on the heels of that is Orbex, who Jamie and I went up to see their facility up in Scotland as well. And that's their prime. So they actually unveiled that on the launch pad a few weeks ago, and it did look super impressive. So that's a full-scale prototype. So they're on their way. So the race now is between Primum Skyrora for the UK and Spectrum, which is EISA Aerospace, and RFA1 in Germany. But not just that. It's the Norwegians, the pesky Norwegians. Got this launch pad. So the Norwegians and the Germans
enemies
might pip the British. Who are you voting for in the Eurovision Song Contest?
Well, you know what? The joke in Scandinavia is that like Sweden, Norway, and Denmark, we all sort of make fun of each other. But it's like siblings. It's like we're allowed to make fun of each other. But if someone else comes and bullies them, it's like, hey, whoa, what are you doing?
Well, it's a bit like us and the French, except we do enjoy people taking the piss out of the French.
Exactly, and they don't actually care about you guys.
No, but yeah, well, the best thing is their rivalry is with Germany. Yeah. They don't no idea about they have no idea about the British. We don't even exist.
Is this then Andoya?
Yes,
the Norwegian space war. Yeah. Well, we have Sweden as well. Just to shoehorn Sweden in there. S-range is ramping up as well. So I think it's going to be a very exciting decade.
Yeah, well, maybe maybe 3 places with vertical launches going up for little small satellite. Everyone seems to be into the small satellite launching space. I wonder if it's going to be.
Yeah, I mean, this is an interesting conversation for sort of space debris as well.
Yeah.
People talk about like if we just it's like microplastics with that.
Yeah,
but
I mean, it's hard, isn't it, with space debris because I think that people get the wrong image in their head of space debris, and it doesn't help with the way that it's shown on YouTube, and it's like, oh, it's an absolute mess up there. It's like, no, space is absolutely vast. And so but it's just that it's moving fast.
Yeah, exactly.
and there's no air resistance, there's no water to soak it down. And so it just stays there forever. So yeah, it's a problem. But I believe that there's a British launch and satellite that's coming up that is another hoovering up of space debris mission. We should definitely do another space debris podcast
episode.
Yeah, because it's we should get a couple of experts in. There's a few more rockets coming up. Obviously, Ariane Space's Ariane 6 and Vega C.
Yeah,
I might have some interesting and exciting news for Vega C, but I'll keep that under wraps for now. And SpaceX, of course, might do their Starship Orbital, which may actually go above SLS as the most ridiculous launch of the year, if it happens.
I mean, it's hot competition this year.
It is hot competition. Here it is. Here's the thing that gets you the most excited. A few weeks ago, on May the 12th, we saw the first image of the supermassive black hole at the center of our galaxy. Were you excited?
I mean, I was just about to say, if you hear me being very quiet, it's because I fainted. No, actually, I remember. So the as many people remember, the first black hole image was in 2019. Mm-hmm. And I remember this very well because I was at a conference and I was like refreshing my phone and then it came out and I was like screaming and running around and shoving my phone in people's faces like, look, it's a black hole. And people were not on my level of excitement and I was deeply disappointed. And it was like a dagger in my heart.
Pesky other humans.
Yeah, I know. Everyone's an idiot. So when this came out, I'm falling over my words. I just think it's amazing.
Yeah, I mean, it was funny on episode 71, and that's a long time ago. We're on 279. It's 208 episodes ago. We talked about that they were gearing up for releasing a picture of a black hole. And it was a toss-up between the M87 black hole and Sagittarius A star at the center of our own galaxy.
Yes.
So, and it was which one are they going to do first? And it ended up a year later being M87. But I didn't think we were going to have to wait 4 years to get...
I know.
So quick question for you, Lynn. What was the delay? Why is the black hole at the center of the Milky Way harder than M87?
So I think the big thing is that this black hole in the center of our galaxy, in the center of the Milky Way, is really, really, really tiny in comparison. And I hadn't actually realized how small it actually was until the image came out and I was reading about it. But the black hole at the center of our galaxy is only 44 million kilometers in diameter, which sounds crazy big, right? But this is actually it's less than the orbit of Mercury. So if you put the black hole at the center of our galaxy where the sun is, it would stop before Mercury is.
Yeah,
That's,
but we'd be screwed.
Crazy.
But we'd be screwed.
It wouldn't
right?
be a. I mean, you know.
Presumably
Mercury would also not be there anymore.
I mean, presumably, yeah. The accretion disk. We're talking about the event horizon of this thing, right? Whereas the accretion disk presumably goes out a lot further.
Yeah.
So you've got this burning hot gas that goes presumably well beyond the orbit of, say, Pluto or something.
Yeah. I don't know the numbers off by heart, but absolutely. And it's worth noting that. So in this image that I hope everyone's seen, this sort of orange thing that we're looking at, that is actually the accretion disk. That is what we're seeing. This is the hot gas that is in orbit around the black hole. And it's sort of like the, let's say, friction between the dust grains that's going around there that is emitting light in the radio wavelength. And that's how we took this image. Black holes are black. So you actually kind of can't see them. And some of the first sort of detections of black holes were simply by seeing that there were stars and objects that were in orbit around some point, and not a point that was like a big, bright, glowing thing. It seemed just like a black point, like there was nothing there. And by working out, because we know for hundreds of years now, we know how sort of orbital mechanics go. And so then you are able to sort of backwards calculate, well, okay, if there are these objects that have this mass and they're going around in this way at this distance, this fast, then you can figure out what should be the mass of the thing they're orbiting. And this is kind of like this indirect detection of black holes in general, because the accretion disk that I mentioned that is glowing, it's very faint. So that's why it takes so long to take these images, and you have to use radio telescopes, and we use them in big arrays. That you have a number of radio telescopes around the Earth that are all working together to get this image. Just using one radio telescope wouldn't really do it.
So, I mean, that's the equivalent, like you said earlier on about James Webb having a small mirror compared to ground-based.
Exactly.
But these ground-based telescopes, by joining up, essentially have a mirror that's the size of the planet, right? Not quite the planet, but absolutely gigantic, isn't it?
Well, this is the thing. And if you think about wavelengths, and if you think back to maybe in school, you learned about the spectrum and stuff like that. When you're looking at the wavelengths of things like ultraviolet light and infrared light and all these things, they're very short. But when you're looking at radio wavelengths, we're talking about 1 kilometer, 10 kilometer, 100 kilometers in wavelengths. So if you think about a small mirror, let's say, catching one of them, I mean, you can't see what you're looking at unless you're taking a big sort of reading, I guess. But again, not a radio astronomer, so I'm sort of riffing here, but
yeah,
I think that's the basic idea.
Yeah, I mean, there's a Carl Sagan quote that always blows my mind. And I don't know whether it's true. I'm assuming it's not now, that it might be a little bit more. But that radio energy that's hitting Earth, like you said, the accretion disk is very, very faint. And that energy in light is reaching the Earth. And if all the observations by all the radio telescopes use that energy as a power station, the power that they would have generated so far with everything that we've ever recorded using radio telescopes would be enough power to hold a snowflake from falling on your hand. So, like, literally, the force of a snowflake landing on your hand is more than the energy in all the observations of in radio wavelengths, which is like, what? So it makes you realize just how, I mean, that is why those pictures are impressive, isn't it? Here's my little stat. So I came up with, if people remember episode 168 or something, when we talked about M82, I came out with the fact that if Earth was the size of a helium atom, right? So you've got a little helium atom. Obviously, you can't see it. No. Then M82, the galaxy that holds this supermassive black hole, would be 2 meters across, right? But it would be 3,000 kilometers away.
Oh my.
So
Okay, yeah.
so M82 is a very long way away, and the
Yes.
black hole would be the size of a speck of pollen.
Wow.
It within that 3,000 kilometer
Yeah.
away place, and
Yeah.
yet somehow we can see it.
It's crazy.
That is crazy. Now this Sagittarius A star becomes even more ridiculous
Oh no.
because
Right, sit down.
so Earth's the size of a helium atom.
Yeah.
But Sagittarius A star would be only 1.5 meters away, so it wouldn't be ridiculously
fine.
far away anymore.
Not at all.
But it would only be the size of a plutonium atom.
So it's not even that much bigger.
No, so like a 1.5. Imagine trying to see
Yeah.
an atom that's 1.5 meters away.
Yeah.
That's what the astronomers have achieved
Yeah.
here.
Wow.
And seen detail. That's the crazy thing.
That's really amazing when you put it that way.
Yeah. I mean, so
And people are like, why is it so blurry?
yeah. So, I mean, the crazy thing is, a lot of astronomers do this thing where they hold their hand up to the sky, and that gives you how many degrees. So, if you get your compass,
Yes.
like your compass at school, and you've got your little points, and you pull it out, and it's making that little V shape.
Yeah.
The degrees between that you're making with the compass is how far those two angular distance
Yes.
is how far two objects are on the points of your compass. Now, if you hold your little fingernail as far out as you can, then you get 1 degree. That's what roughly 1 degree, right? And then that's 1 degree is broken up into 60 minutes, and that each of those minutes is broken up into seconds.
Yeah.
So
Sorry, guys. The astronomers are weird like this.
Yeah,
They're
so the seconds are only 1/360th of your fingernail.
Yeah.
Whereas these objects are like 0.00003 arc seconds. So in other words, a 10,000th of that, and that's what we're seeing with these telescopes.
Crazy. I think I remember. I could be totally wrong. Write into the show if you think I'm wrong. But I think I remember reading 1 arc second is basically like holding up a sewing needle at arm's length, and it's the size of the hole where you thread the needle. So imagine that within that little hole at an arm's length, then you have like a fraction of a percent of a sliver of that.
Yeah.
It's just unimaginably small. There's nothing that we can compare to that we can see.
Yeah, and just seeing detail on that, and that, I guess that's the incredible thing. But it's because you can't even draw it on a piece of paper.
No,
like I've said, like you draw a dot on the piece of paper that not
it's
even
already too big.
Yeah, it's already too big, and then you've got to have a piece of paper that's at least 2 meters big to draw another infinitesimally small dot, and then you've got the scales right. Yeah.
Hey, didn't they say it's like a donut on the surface of the moon? I seem to remember that was an analogy.
Yeah. So if you saw a donut on the moon from here.
So you've seen a donut, perhaps. You kind of know what the moon is. So there you go.
But it's even then, it's quite hard to visualize how far away the moon is because it looks so big. Yeah, but then you hold it. But you can cover the moon with your little fingernail.
Yeah.
Because of the moon illusion, it's very, 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 very strange. But there's already amazing science that's coming out of this data, isn't there? About the supermassive black hole Sagittarius A star at the center of our galaxy, right?
Yeah, absolutely. I mean, this is the thing. I'm a very much like a puppy or goldfish that like every time there's a cool new thing happening in astronomy, I'm like, dang it, I should have specialized in that thing. The black hole is my most recent thing.
I was going to say, isn't it obvious if you're astronomer, you should be studying black holes? They are clearly the coolest thing they're clearly the coolest thing in the universe.
Yeah,
like most of the
maths for me.
Most of the entropy is all caught up in them.
I know,
and that's all that matters.
Yeah.
Here's an interesting one: is that when we see the black hole in the middle of M87, it's got like little patches that are more orange in other places because of this relativistic way that the accretion disk is whizzing round, but it's slightly different on the picture that you see of Sagittarius A star, although actually the two pictures are remarkably similar, but we'll get onto that. But the reason why it's different is because we're the one that we're seeing in M82, we just happen to be seeing it face on, right? Because because it's actually spun up so that it's in the same orientation as its galaxy, in the same way that the sun spins with the orientation of the disk of the solar system. So does the black hole at the center of M82. But the curious thing is that our black hole at the center of the Milky Way isn't rotating like the sun, as you'd expect it to, with the disk. Right. But it's kind of at a jaunty angle of about 20 to 30 degrees.
Yeah.
And so that's been quite fun for them to unravel.
Yeah. I think because people often picture black holes, you know, really the only way we can even attempt to sort of visualize what's going on in a black hole is by doing these sort of, a bowling ball on a trampoline type things where you have the ice cream cone suddenly. But then that makes people think about gravity, and then you're picturing like a hole in the ground kind of thing. So you sort of picture it always being like pointing downwards. But I mean, black holes, you could like everything else in the universe, everything can be at whatever angle nature decided it to be at upon creation kind of thing. So it's very, very interesting to me or for the astronomers that are working on this to sort of figure out what we're even seeing. And this is something that I give a lot of credit to, or we should give a lot of credit to the role of computers in astronomy, because today astronomers are, I say self-deprecatingly like we're glorified programmers, but it's kind of true because we do use, in astronomy, you're dealing with such huge numbers, such crazy physics phenomena, so many physical circumstances that cannot be recreated in the lab. And so you have to deal with enormous data sets and weird things. And so a lot of the time, the best way to figure out what the heck you're looking at is to run a simulation and then see which one sort of matches what you're seeing. So I think there's going to be a lot of work for a lot of people for a long time.
Oh, yeah. And what's interesting is that there's some space telescopes going up that might even be able to get actual pictures of movement so that they can actually see what's going on in terms of the kinetics of it all. Because at the moment, it's like still pictures, isn't it, really, at the moment? Yeah. Until you get enough resolution so you can actually see how the gas is moving and why it might be moving that way, et cetera, et cetera. Yeah. But what I thought was interesting is that if the black hole is at the center and it's given enough time, it should kind of orientate itself to the sweeping arms of the galaxy. Yeah. But what seems to be happening is that these, like you said earlier on, the stars that are orbiting, that we first knew that there must have been something very dense and very big there because you have these orbiting objects. They seem to be having more of an effect on the black hole and therefore tilting it off its axis. Yeah. Remember a few years ago where they had the Fermi Bubbles? Do you know the Fermi Bubbles? So these enormous structures, if we're talking about my scale that we were talking above, where they are 3 meters in length, these things. So absolutely gigantic, 50,000 light years long. That's how, so these are gigantic structures. So they think that obviously one of the main culprits of these big bubbles of gas is, they think, Sagittarius A star. Yeah. But they seem to be coming out of the disk perpendicular. So they were expecting Sagittarius A star to be, perpendicular to the, like the sun is to the solar system, on that same angle. But it's not, it's tilted up. So why aren't the bubbles tilted up? And they think it's because it might be the bubbles are made up of lots and lots of different times where the black hole has been feeding on all the gas that's around it, and then burping out these chimneys of hot gas after it's fed on the gas around it, and then and chucking them up away from the plane of the galaxy. And it's that, they look incredible. And the Germans and the Russians had an E-Rosetta was another one that took even bigger structures than the Fermi Bubbles. So this, that's been happening for absolutely ages, these enormous bubbles of gas. So, but we're really lucky that it seems like our black hole isn't particularly active.
Yeah, it's a kind black hole.
It's a kind black hole, but it looks as though it has been very active in the last few million years. because of these bubbles and the way that it hasn't sort of jigged itself to be, in line with the plane of the galaxy. It's like, it's super interesting, isn't it?
Yeah. This is kind of a recurring theme now on this podcast, that like the crazy thing with the universe is that you kind of can never confirm what happened. It's like a CSI scene that we burst in on, like something really weird happened here, but there's never going to be any DNA prints left behind for us to figure out. And like, even if we can say we think that these kinds of phenomena, if it happened in the sequence, would leave a mark similar to this, like we can never actually know for real what actually happened and what the history of our galaxy or our universe is in detail.
No, in fact, I used that analogy last month, didn't I? That actually I've been thinking about since. And it's like, maybe, as mathematicians and physicists, they like everything to be ordered and think that they can kind of, well, I don't think that they think that, but so there's a kind of feeling that there is that you can kind of reverse things and push things forward. Yeah. But it's a bit like thinking, if I open up my washing machine, can I truly work out the order that I put my clothes in from knowing all the physics of the washing machine after it's been running for 2 hours? Well, clearly not. It's too chaotic a system, isn't it? And I guess that's what you're facing there, is you've got this absolutely chaotic system that's affected by lots of things, and it's probably unrewindable, so that we won't know why it's like that to some extent.
Exactly. And there's too many ways in which it could have arrived at something. Like 1 + 1 = 2, 2 - 1 = 1. Okay, you've got back to where you came from, but it's not like that in this case. It's not like input goes here, output comes here. It's such a enormous, as you said, chaotic system. It's like turbulence or something, or like the weather. We can't even predict the weather on this planet. And similarly, you couldn't take the weather today and figure out what it was 2 weeks ago. So, no. Now imagine trying to do that with the universe, where we can't even really observe things that well. We're only just getting to look at the black hole in the center of our galaxy.
And it's not just a measurement problem either. That there is some hints that some things are so chaotic that there is no that you actually, even if you knew every single thing about that system, you couldn't rewind it. That there is actually true chaos as well as just quasi chaos. Yeah. So any other thoughts on that black hole?
First of all, I can't figure out what they're going to do next because those were like the big two, right? No, I just think it's amazing. It's one of these things, and there's a couple of sort of core memories in science growing up, and like I remember finding out about that relativity was a thing. And I remember hearing about black holes for the first time, and I remember hearing about this and that. And if I had known that we would be getting these kinds of images, like in my lifetime even, maybe other people who knew more about this topic weren't as surprised as I was when these images started coming out. But I just think it's amazing. I just would not have thought we would be so lucky to see it.
Well, I've got a feeling that if you asked like very clever physicists from 20 years ago whether it would be possible, I think that they may have actually thought it was not, because it's such a technical feat, isn't it?
Yes,
that does require like brand new computing and brand new statistics and brand new equipment and brand new measurement techniques, etc. There's so many bits of technology that are convergent to that point. That's the annoying thing about the picture for me, because it doesn't quite say how amazing it is. It's like it's annoying. Yeah. It's like it's like the ugly creature in the zoo that's really amazing, but no one looks at it, and then everyone goes to look at the pandas and the lions.
Don't judge a black hole by its cover photo. I don't know.
Yeah, well, I think if you could get close to one, it would be pretty awesome.
For the small bit of time before you get spaghettified, I guess.
Yeah,
then you wouldn't have many thoughts about it.
Well, get this. I think M87 is because it's 6,500 million times heavier than the sun, and it's 2 billion kilometers across. 2 billion kilometers across. Wow. it might be so big that you don't get spaghettified. So there is this thing that
there's a plus side.
Yeah. So
There's an upside.
so the very big black holes,
Yeah.
you wouldn't even notice going over the event horizon.
That's how I want to go.
Oh my! Can you imagine?
That sounds great. It's like the hypoxia thing, except
I don't think anyone's ever going to do it, but it would be weird because
Yeah.
you'd sort of look out and the whole of time would be appearing in front of you, like the whole future.
okay, no, I really want to go.
Yeah,
Sign me up. That's
it's
I will
crazy.
experiment.
I don't. Whereas everyone watching you going over that bit would see you frozen
like
at the
forever.
edge. Yeah, forever.
Yeah.
It's slowly fading away, apparently, which is just seems so science fiction, but the maths adds up.
This is the sequel to June, right? Or something like that. I wonder, do you think maybe that the next thing that they'll do is to just get more observations of these two and just try to improve on the image they already have, maybe?
They'd already done some additional things, hadn't they, with the
They added
M87
the magnetic
one?
field lines.
Yeah, and things like
so
that.
maybe stuff like that.
I think the real treasure trove is the actual data without the photos attached to
Yes.
it. As in that's what they're really getting the insights from, is just the amount of data that they're pouring through. And this data's really old, but there's a lot of it.
Yeah, that's the thing.
And you kind of have to get computer time on supercomputers.
Yeah. Well, and I mean, in astronomy, it's not it wouldn't be the first time where people take data that was collected from a long time ago, but people didn't really know what to do with it at the time. And then decades or even centuries later, people can actually start to analyze it in a more proper way. I mean, people are taking the Venus data from the 1970s and doing stuff with it now, today.
And yeah. Well, yeah. It's just,
So who knows? Who knows what people will do?
well, yeah, I mean, they're still cracking open moon rocks
Yeah.
and looking at them and you know, from 69 and from 1970. Yeah, it's crazy, isn't it? There's one thing that we didn't mention is the fact that because these pictures look amazingly similar, it shows that general relativity is pretty
You know
spot
what? General
on, right?
relativity, it kind of works.
and the differences are more to do with the material that actually surrounds the black hole and not the black hole itself. But they're so ridiculously similar. It's like, well, you know, these objects.
It's just the same thing almost. Yeah.
They're exactly how they thought they were going to look. And
Yeah.
I guess that's pretty disappointing in some ways.
Yeah, I guess it depends on how you look at it, kind of thing. But I mean, general relativity, it's this is the kind of thing as well where I wonder, should black holes be considered like a branch of cosmology almost? Because it's kind of one object, but like the kind of physics that it does is just so much closer to sort of the fabric of the universe than being like an independent object.
Well, it's almost like you get the particle physicists get excited about black holes because it explains.
Rightly so.
Yeah. Well, everyone gets excited about black holes.
But they really get excited.
I mean, like I said, you know, Einstein had never heard of a black hole. He died before the phrase black hole was ever come up with. Yeah. And then in the 70s, everyone just thought that they were a mathematical sort of silly
curiosity,
thing. That had kind of been Schwarzschild died in the trenches as a German soldier.
It's crazy.
Like working this stuff out.
Yeah.
And like, so he was completely unknown. And then Roger Penrose a few years ago gets the Nobel Prize because, you know, black holes have come of age, as it were.
They've become the cool thing now.
Well, it's like, there's no denying that they exist now. And I guess that's why those photos are amazing, because it's like, oh my, they are really, actually there. Seeing is believing, isn't it?
Yeah. And I think maybe, you know, especially our younger listeners, myself included, really, maybe don't realize that the leaps and bounds that have been made in astronomy in the last decades, in the sense that so much that was hypothetical quite recently is now bona fide, proven sort of, let's say, fact. We have direct images, direct observations, direct sort of proof, or as close to direct as you can get in astronomy, to all of these things existing, like exoplanets and black holes and all of these things. It's just
what we're waiting
humbling.
for. It is very humbling, but a lot of it is as we expected. I got a feeling that James Webb is going to see something that's not as we expected, and it's going to blow the whole thing up, just as things like the
just
large...
as we're starting to think that we understand things.
No, just as things like the Large Hadron Collider are doing the same thing, where the standard model of physics is going to start cracking apart, just as these large cosmological things start cracking apart, and it's new physics, and we're back in the game. Neo-physics. And we'll invent faster than light travel, hoverboards.
Yeah, exactly. We'll find
upload my mind to the web. Yeah. It's going to be
a utopian society,
a glorious utopia.
What a positive note to end on.
Yeah, it is a positive note to end on. Shall we have a listen to mine and George's chat about languages, just in case someone lived near a black hole?
Just in case.
In fact, societies might live on the edge of black holes because it's a very good place near the end of the universe to eke out the final bits of existence of the universe using the energy gradient at the edge of black holes. It might be the last bastion of places to be if you're intelligent.
Why are we wasting our time trying to terraform these stupid rocky planets
when we
got this perfectly good black hole around
go
the
live
corner?
on the edge of a black hole?
Exactly.
Yeah, I think you need a very, very, very sophisticated technological society. But anyway, Ekute,
the Interplanetary podcast, putting the ace back into space.
George.
Yo.
Nice to see you, old bean.
Nice to see you as well.
This is going to be like our little monthly slot, the George Russell Crazy Space Ideas slot.
Is that the name pending?
Yeah, name pending. We'll come up with something, but maybe listeners can come up with a nice name for the section. George, what are we going to be doing this week?
We're going to be talking about arrival, languages, and space languages.
So this is it. So this is the premise, isn't it, for this, is if we make contact with aliens, can we actually talk to them?
It's
something I've not really thought about before, but you kind of take the premise of, oh yeah, it'll only take a second to work out the language, but it really isn't that simple, is it?
Well, maybe not, or maybe. It depends on, a lot.
Well, for my little bit of research, there seems to be two competing schools of thought. The Chomsky generative view, that somehow through a gene that happened some kind of evolutionary advance where just one human had this bizarre genetic makeup that gave them grammar, essentially. It's hardwired into humans, this ability to come up with grammar. But there's also the cognitive view that's more to do with our experience in the world being more important than the generative view of this, the grammar. There's so many problems with it. There's humans are able to communicate using light and sound, but what if, other animals use different wavelengths of light to communicate and see the world?
Yeah, it could be magnetic field or something like that.
Could even be taste?
Even if it is sound, English or any other language for that matter, or let's say English, for example. English has something like 45 phonemes, but there's 200 or so that any human can make, right? The physical limit is somewhere around in the hundreds, right?
So when we're talking about phonemes, we're E, A, U, O,
those vowels, and then you've got all of those sounds. And obviously a alien would have a different vocal cords, different tongue, different teeth, even if it has those features. So even if we wanted to talk an alien language, we'd have to have a completely different mouth just to make these sounds, or a completely different way of thinking just to hear these phonemes, even if they have them,
Yeah, I can't. The creating the sounds might not be a problem, isn't it? We're pretty good at synthesis these days, and we've got good sound systems and et cetera, and you're playing into my field here. But I agreed. There might be the problem straight off in the fact that they might be talking in such a high frequency it's outside of the the 20 hertz.
What I'm trying to make is
kilohertz,
we could never have a one-to-one conversation with an alien, even if you understood their language.
Well, I mean, it's unlikely.
Yeah.
It's unlikely. I mean, it would
have to be through
know.
computers,
Yeah. I mean, in Star Trek, that all the aliens speak where just about the right frequency. In other words, all the information's round about 4 kilohertz. And they all seem to be able to make the same kind of phoneme and
Klingon isn't really that weird. It's
not weird at all.
It's like not even like there are languages on Earth that are more different to English than Klingon is to English. It's really Klingon isn't as far as languages can even go with humans, let alone how far weird languages could get with other alien species.
Well, I'm going to mention one other thing that makes it ridiculously difficult as well. Of course, when we look at the world, we have this kind of feeling that what we're seeing, like a cup on the table, is what it really is. But of course, it's not. It's your eyes pick up the signal of the cup as the light bounces off it. It goes into your visual cortex, and then your brain makes a picture up that it feeds to your consciousness, the kind of what you actually perceive it as. So your brain is making up what the outside world looks like, and based on the inputs that are coming in. And of course, something like a dog has volumetric smell. It can smell the volume of things, which is bizarre. And therefore a dog's experience of the world is completely different. So its language would probably express that if it had a more sophisticated language. Maybe dogs are trying to tell us stuff, but it's so crazy that we can't understand it. Just maybe.
Yeah, I mean, definitely the way in which you perceive the world and, the senses you have will affect the language that you ultimately have. Like, for example, if you didn't have eyes, if no one had eyes, there would be no word for look or see or colours even. And
well, yeah, I mean, our language would change dramatically, wouldn't it? The language of objects and description of objects would dramatically change, and maybe you'd have a much more hearing based language.
Because even blind people, when they think of a car, they think of its features rather than the actual form of the car. So they'll think of like a door and a steering wheel and wheels, but they won't necessarily map that into one large cohesive structure. So like the way in which you think of even structures like that could depend on whether or not you have eyes, or whether or not like depending on the senses you have, that will change your language and change the way that you communicate.
So Chomsky, he advocated this thing called the generative view. Basically, somehow we've got this internal structure, and basically it means that in our head there's a certain set of sounds and that we can only have in a certain set of orders that would make up our grammar, and that's kind of hardwired in. So if you're a baby, the kind of the set that the language that you're born into activates that set of sounds, but that it's really limited. So a baby can be born in any language and learn that language. That's the extraordinary thing. A baby from any culture, from anywhere in the world, you stick it with any humans on Earth, and it will learn the language. And I think that's one of the reasons why this generative view exists, is because there has to be something in there for the baby to latch onto and to be activated. And I could understand that. And so Chomsky, this is what Chomsky says about aliens. This is his quote. He says, "If a Martian landed from outer space and spoke a language that violated universal grammar, we simply would not be able to learn the language the way that we learn a human language like English or Swahili. We're designed by nature for English, Chinese, and every other possible human language, but we're not designed to learn perfectly usable languages that violate universal grammar." So Chomsky actually believes that because of this hardwired grammar element, you couldn't possibly learn an alien language
unless you're lucky,
no, you'd have to be stupendously lucky. This is like a sort of,
there is quite a broad range of what languages can look like in English, for example, in human.
Yeah, well, this is the point, and I think that you know about one that kind of slightly violates this Chomsky viewpoint anyway.
Yeah, I mean, so in the film Arrival, which is one I originally thought of when I was thinking of this, there's this language in that film that basically, once you learn it, it grants you abilities such as the ability to see into the future, which is kind of absurd, but is like it's rooted in a sort of realistic scenario, isn't it? Yeah, it's based on what's known as the Sapir-Whorf hypothesis, or usually just referred to as linguistic relativity, where basically the language you speak affects the way that you think in like dramatic ways. Sometimes in the film, the ability to see into the future. But there's a tribe in the Amazon which called the Praha people, and obviously they speak the language Praha, and it's incredibly weird for lots of reasons. Right? It's like completely changes the way that linguists have thought about the universal grammar and the universal things that all languages have. So, for example, it's really simple. For example, so it only has 11 phonemes, only 3 vowels, and the rest are consonants. And
I mean, English has only got 5 vowels, and how many consonants?
It's got way more than 5. It's only 5 letters that represents vowels. It's got something like 15 vowels.
Oh, really. There we go. Yeah, okay. How many consonants have we got? How many kind of phoneme sounds have we got?
It's something around 45 or something. So it depends on the dialect, but yeah.
Yeah, so it's a lot more.
A lot more, yeah. It's usually languages around there, and there can be even languages hundreds. But the point is, it's really a simple language. So, for example, there's not a word for mother or father. There's just a word for parent, and there's not any words for cousin or grandparent or anything like that. And it's so simple that there isn't even numbers at all. Like, you can't say there's one thing or there's 2 things. You just say there's some things or there's many things. So there's a distinction between having a lot of stuff and having some stuff, but then there isn't a distinction between 1, 2, 3, and so on. And another unusual feature it has is it doesn't have infinite recursions. So pretty much every language other than this language, you can infinitely chain words into an infinitely long sentence. So, for example, in English, you can say he said that, she said that, he said that, she said, and you can just chain that forever. I
mean, you wouldn't, but
you wouldn't. But you could.
I mean, we tried in this podcast a few times, but
that was the first take.
Yeah,
but but in this language, there's this weird. It's designed as such that you can't talk about abstract concepts, and the way that the original researcher of this language, is
this guy Everett?
Everett, yeah,
because he props up a lot. This I think if you wanted to look up a sort of superhero in this field, it's Everett, isn't it?
Yeah, he's really good at like going into tribal communities and working out their language and
because there's some really great demonstrations of this Everett guy who can, if they don't have a shared language, he can walk in to a monolithic language, a language that's orphaned, as it were. So a language that has no root in any other language. It's a language that's developed all by itself and away from everything else. So that there is no commonality between that and any other language. He's able to first of all sort of point at sticks and go, what's this? What's this called? And they kind of understand that he's asking them to name what he's pointing at. So they'll sort of say a stick. And then he'll sort of pick up other objects like a stone, and they'll say, oh, that's called a stone, or whatever their word for it is. And then he'll do things like drop the stone and ask them what's happened, or throw the stone and ask them what's happened. So he starts to build up verbs, nouns, and hints at their grammar, so that he can understand what's happening. And he reckons in a couple of hours he can start to, this is a very skilled linguistic, field work. Yeah. And he demonstrates this. So you can bring on like a mystery language, and he will be able to start a conversation within 2 hours with this person, which I think is absolutely amazing.
But yeah, it's incredible that you can learn so quickly. But yeah, his work on the Praha people originally started as a Christian missionary. So he wanted to learn the language and then to explain, the Bible and everything and Christianity with them. The problem is, though, their language doesn't have any ability to think about or talk about abstract concepts. So you can't even, like, where would you even begin trying to explain like anything to do with religion or supernatural?
So basically, if it's not there, if it's not in front of you, you can't talk about it.
Pretty much.
It becomes meaningless.
If it's not either, something in your memory or something in front of you, like something that you can observe firsthand. So for example, you would say Jesus Christ, and they would say, where is he?
And until they've seen him or have a memory of him, they can't even get the concept.
The language has such an insane effect on their cognition that there's at one point the Praha people asked Daniel to teach them basic numeracy skills. And after 8 months of enthusiastic but fruitless daily study, the Praha couldn't even count. Like, most of them couldn't even count to 10, and none of them could add 1 and 1. Like, understood the concept of adding numbers, which is, I don't think there's ever been like even close to this effect of a cognition shown of a language.
Yeah, it's one of, if not the most basic language that's ever been sort of come across in a human tribe, presumably.
But
and there's no reason to think that this particular group of humans are thick or anything.
No, it's not like genetic. Yeah, of course.
So it's literally, because I guess if you got one of their babies and stuck them with an English family,
So the Praha are the last tribe of a much larger cosm of tribes, and all the others have gone into Portuguese-speaking society, and they're like fine, right? They can do maths and do everything. So it's not like a genetic thing. It is purely like the fact that they can't think in the way that you can't. Yeah, they can't think in.
Yeah, I mean, that would explain why the English are just cleverer than the French. Maybe it's just a language thing, isn't it? Yeah. So I mean, but in all seriousness, I suppose we could go around the world, and that certain language people that speak certain languages may be at an advantage with some of their cognitive skills.
Yeah,
or do you think that languages are probably homogenized now?
I think there's a fresh threshold where your language is essentially in the category of it could do everything, basically. Yeah. So basically all modern languages have a word and a way of saying anything to some level of accuracy.
Yeah,
so English,
understanding
Mandarin, Arabic, all of these languages. It's really only tribal languages and groups and communities that live in very niche kind of, environments that we see this kind of really simplified and weird language.
If we moved away from Chomsky a little bit, because that kind of does suggest that Chomsky's not right, but also the other thing that kind of makes Chomsky seem like he's wrong about this idea that grammar's hardwired and you need it is the fact that neural networks that learn languages don't require it, so that they're able to learn languages and do it without having kind of internalized structures in the first place. So neural networks have been able to sort of learn languages. The argument for Chomsky, however, is the fact that no other animal other than humans have languages, have multiple languages, have an actual language,
a complete language.
A complete language. Like whales can communicate, but they don't have a language.
So for example, animals have languages where one word basically has a set meaning. So it's like it's basically a language made of set phrases. So imagine a language only made of things like, long time no see, or hello, or goodbye.
Yeah, and you can even do that. Obviously, chimps have a very, very broad set of those kind of phrases.
But you can only get so far.
Yeah, you can't communicate with chimps. You can't have a conversation with a chimp, and they're our closest. Genetically, and their brain is very, very close, and they're super sharp at certain things, but they don't have language. Right? Is that I'm right in saying that, aren't I? They don't have language per se.
Yeah, like they don't have a language which allows arbitrary complexity, I guess is what you're trying to say.
Yeah, and so that kind of plays into the Chomsky thing that there must have been there's some genetic evolutionary point where we've somehow got the ability for language. But there was also this cognitive view which is like the neural networks thing, that as long as you can talk about things like movement and future and past and similarity and difference and agent and object, the moment you start to understand those concepts, which is much more, I think, what humans do more than any other animal, that we're able to kind of understand those sorts of concepts. Those are the things that allow us to have language, that rather than like this kind of concept of internalized grammar. What do you think?
I mean, I think if you look at like how different languages are across the world and how different their grammars are, especially like if you like, you might not see this if you're English, your first language is English and you're learning something like French. But if you learn Korean or Japanese, you'll see just how different grammar can actually get. And this kind of intuits to say that that there isn't this base level grammar, that really we do generate grammars, and grammars can change over time through memetics.
So in other words, the semantics, the structures of meaning are more important than the structure of grammar, the syntax.
I mean, of course, there are like fundamentals in language like that. All languages have a separation between nouns and verbs, for example.
Some languages have the verbs at the nouns at the front, and some of them
there's like word order, but there's even, you know, there's weirder stuff on that, like sometimes they don't use word order to denote the function of a word, but instead like markers, so words that go after a word that just tell you what its use is in the sentence, for example. Yeah,
but that for me sounds more like convergent evolution. So you know that the eye, for example, has developed several times. You know that
wings,
lots of and that idea that everything wants to become a crab.
Crabs have evolved like 7 times.
It's ridiculous, isn't it? That's the weirdest fact ever. But so crabs have evolved lots and lots of different times, and so maybe this kind of that there is a convergent evolution, which I think is probably the thing that kind of muddies the water in some ways, in terms of it's hard to unravel what was convergent and what was innate.
Yeah,
if you see what I mean, in terms of that story.
Because ultimately, language is just logic, right? It's just a transcription of logic in a sort of efficient way.
Yeah. So if we go back to aliens, it's like, so the real hope is that aliens will have some form of shared experience, isn't it? So that they perceive time as past and future, that they have maybe biological similarities in terms of they have parents and they have offspring. You know, if they're breeding. So there's things like that, and maybe they understand things like, you know, this cause and effect. I mean, agent and object and all those kind of things. And I guess if a animal becomes technologically advanced enough to be able to communicate across space, which is that they're bound to have a lot of these similar constructs. So there's some good news that you know, a slightly more optimistic viewpoint than Chomsky has, where it's essentially almost impossible to communicate effectively with an alien civilization because of this view that somehow the language is an innate.
Also, I think we should bring up constructed languages here, because there are languages like Lojban, which is a constructed language made based on predicate logic, which is basically this mathematical logic systems. And there are people who speak it fluently. So if we're able to speak languages like that, there is still hope that we can use that language as a lingua franca.
That seems to blow Chomsky out of the water, isn't it? If you could learn it and be fluent in it. And actually, I suppose that might be a way that you could basically get the aliens, or they will have probably have learned this as well, that you could learn one of those types of languages that are more logically consistent, and then you have a shared language that you
we develop a lingua franca that uses predicate logic, and that could be like the best way to talk to an alien, through a lingua franca that's constructed for that purpose.
Yeah, I mean that for me is kind of like almost one of the crunch points, isn't it? I mean, it's in terms of the communicating with different sounds, that seems to be okay because obviously
you can just write it down. Yeah.
Well, whales make sounds in a very low frequency, but you can always pitch shift it up, and hear what the heck's going on, so that your ears can hear it, for example, or even represent it on a computer. The computer translates it and represents it in a different way so that you can understand it. The frequency that we speak at, by the way, is so important that the human ear canal resonates at the frequency where all the information is. That 4K frequency is why you lose your hearing at 4K.
Presumably, all information in language can be converted into ones and zeros, so you can take like anything spoken in English.
But I guess you don't really want to do that because then you're dealing with sort of statistical analysis rather than.
You can convert it back into
I mean, I suppose that's
like a representation, like a sort of romanization in some way.
There might be other ways of, we're looking really simply at the ways that you could translate a language, because we're just, even when we've been having this discussion, we've been just talking about it as being sound. But I actually think the likelihoods of an alien talking with sound, even that seems to be quite remote as well. It could be they could communicate through bioluminescence, like cuttlefish, or they could,
or the animals in heptapods in the Arrival films.
Yeah, exactly. So
but ultimately, I think all civilizations ultimately have a secondary kind of some kind of writing system. Maybe not with a pen, but some way of grounding down words into
and we haven't
physical medium.
And we haven't even talked about the kind of meta language. You and me are talking now, and we're gesticulating, and we're sort of putting pitches in our voice, and there's so much other information in our language, and I wonder if that would ever be able to be translated for an alien. I think the fact that they might be able to understand basic language and would get points across. But here's the danger: is the fact that so much information is in our gesticulation and the way that we express ourselves, that even in a situation between humans, you're quite likely to make a mistake that ends in war. But if we're talking to aliens that have got no idea about what our gesticulations,
that is a plot point in Arrival.
Yes, because
they say I've given you a weapon.
Yeah,
and then the UN or whatever here's the word weapon from them, and then. It's like, that's it, nukes out.
And this guy Everett says that those kind of mistakes are absolutely inevitable, but you have to sort of remain calm and
because being in tribes it can be extremely dangerous.
Well, it's insanely dangerous because you say the wrong thing and you've suddenly
there's a funny story of that where there's another bizarre language, but for different reasons. That this guy is I think it's Australian tribal language, like on some island somewhere. And essentially, they've got this weird system where dead people become their names become words in the language, but it also is like swearing at the same time. So basically, their entire language is made of curse words, and so depending on like where you are and what setting you are in, you have to basically change your entire language.
Oh my god, that language sounds so stressful.
Yeah, it's probably the worst.
It's kind of like a language designed to trip you up.
I don't understand a lot of it, so we can put links into the description about that, because if you want to look into that further. But it's this language where basically it's really easy to mess up in that one.
Yeah. So overall, then, George, how optimistic are you that we could talk to aliens?
I mean, not like I'm talking to you right now, but through computers, I think it's just as we can, use Google Translate and stuff to speak to anyone or most people. I think the same is true for aliens. We can work out some kind of lingua franca or use some translators to speak to them in that way.
Yeah, I mean, I don't buy the argument that we can't communicate with other animals on Earth. Therefore, what chance have we got for aliens? I think
because they would be making the effort to talk to us.
Yeah, but not only that. I think that there is a sort of. I don't think that you. I mean, we're talking about communicating with technologically advanced aliens with cities or the equivalent of what a city is, or some form of if they become spacefaring, if they're able to build radios, etc., I think once you get to that level, I'm much more with this cognitive view that you can. I mean, here's me knowing nothing about languages, but it seems to me that this cognitive point of view.
Well, I think most linguists are on that.
Well,
it's
apparently the jury's out on it. Apparently, the cognitive and generative thing it is definitely winning. But it's not a slam dunk, apparently.
We can't say.
But then I think that's because Chomsky is so held in such high regard. I can't help feeling that he has that. Maybe it's a classic one. It's like it's like the English scientists were so enamored by Newton that they carried on doing the same kind of calculus as he was doing because it was Newton, for goodness sake. And then the French were so sort of the English, stupid English, and then they went miles ahead with calculus because they weren't in awe of Newton. So maybe a similar thing's happening with Chomsky in language. I don't know. I mean, again, I'm just riffing in terms of things that might have happened, but. Yeah, I think you're right. I think we will be able to talk to aliens. But the one thing that I think is really sad is that I really, after reading all about this and you telling me a lot of the kind of stuff that you've said, I don't think we'll ever understand things like alien poetry or alien music or anything like that. I think it's because
we will never become fluent in that language.
Well, I just don't think we'd ever be able to understand it. Maybe our offspring would. Maybe if you stuck a baby with them, that they would. But I think that once you kind of miss that opportunity, like you said, those people, they couldn't add up because the concept was so weird. So it's like unless your people grow up with those people, unless you're a baby within them.
Yeah, I mean, the brain is really plastic. So
I mean, the baby thing's really interesting. Whether if you stuck a baby with an alien civilization, if it could do it, particularly if you have a baby that lived with humans and with aliens, then they could act as this kind of intermediary and say this is the true meaning of this.
Yeah, I think Michael Stevens from Vsauce said that if he could devise an experiment and set aside ethics,
damn ethics.
Yeah. If ethics weren't a problem, he would do these sorts of linguistics experiments with babies where you have a baby grow up without language and see its effects.
That would be pretty mean.
It would be mean, which is why
it kind of has been done. I mean, there's that terrible story of the girl that was sort of locked away and no one spoke to her. And the problem with that is, if you don't hear certain phonemes,
you'd be mute pretty much.
You can't really hear it. Even and they spent ages teaching her words, and she could basically pick up the odd noun, but the opportunity for grammar was completely missed.
Writing, though, you could learn.
Yeah, apparently, yeah. She kind of, I mean, she could communicate, but she had no language essentially. So there is a window where as a baby that
once you pass 11 years old, it's really hard to pick up new phonemes.
Yeah. Well, yeah, which is in all seriousness is why the Chinese find it very difficult to hear the difference between w and r. They for them it's actually difficult.
Or LNR or
LNR, yeah. L and R. Yeah, so and it's not a sort of it's not a joke. They can't really hear it, and even Austrians struggle between w and v. And so Vienna and Vienna may actually sound the same.
And for English, we may not differentiate between the sh and sh in English.
Yeah, exactly. So
in the Chinese, or the aspiration difference in Hindi, so they have a p and a th.
Yeah, exactly. So, which is another kind of indication that language is troublesome, to say the least, in terms of communicating.
But you can always learn writing systems, which I think is important.
Yeah. The writing system thing's really interesting, actually, isn't it? And I suppose maybe diagrams and drawings and art and things like that is an incredibly rich way of communicating as well.
Yeah, logography and things definitely is helpful.
Yeah. Indeed. Well, this has been a very interesting chat, George. I'm glad you've joined me for George's Mystery Subject of the Week.
Nice. TM.
So, yes, if there's anyone out there who's a kind of space linguistics expert, please let us know, and we'll get you on the show, and maybe we can, in a future show, give you
all 7 of you.
All 7 of you. Yeah. If Mr. Everett's out there listening, then please do get in touch. Thanks very much, George. I'm going to go back to the main show now.
The Interplanetary podcast is alive!
Pity I didn't know you were a linguist person.
I know. I would have joined in and
because that would
gotten
have been
excited and rudely interrupted 500 times.
where we can have part 2.
Yeah, a follow-up.
Little follow-up. What's Swedish for part 2?
Del 2.
Maybe we can have det 4.
Yeah. And work on the pronunciation. No, I'm kidding.
Whoa, sounded great.
Zing. No, I'm kidding.
Ouch.
Did you know? Have you heard this this thing about colors in languages and at what point in time they were invented? There's this great thing about the color blue and how we think that in most places. And again, sorry, I'm not a linguist. I'm just paraphrasing something I read once upon a time. But the color blue, because it kind of doesn't actually come out that often in nature as a very strong color. And so it was pretty late on that it was given a name. Like black and white, it's pretty early on because it's dark and light. And things like red was given a color because people were pointing at blood and saying red. But some of these colors, like, if you think about it, if you don't really need to describe it in that much detail, you won't really need a word for it. And I mean, we say that blue and green are 2 different colors, but you could also argue that like turquoise and forget-me-not blue or Egyptian blue are 2 separate colors. Like there's still just a slight difference in hue and things like that. But we're like, well, no, they're both kind of blue. It's like, well, you could say that blue and green are just kind of like shades of each other, you know?
Yeah, well, we had a ridiculous question in a quiz the other day that was, what color is copper? Is it brown or orange?
Oh,
it's like,
Jesus.
well, it's not.
Both?
It's not. Well, exactly. It's a reddish brown, isn't it? Which is a kind of orange. And it's like, what makes it copper is its reflectivity, not its wavelength, right? So that's what makes the question absurd.
That's so
or
cool,
unless
actually.
someone's
Well,
got
there you go.
Yeah, so I refused to answer the question. In the end.
just not available.
I stormed out the pub and demanded my quiz money back. No,
Threw your copper-colored beer on the floor.
I did. Oh. No, actually, it was people quizzing me down the phone, which made it even worse.
Oh, so
they were having the quiz and they were phoning me up to cheat.
Oh no!
Or at least
illegal.
To get. I know.
Well, it's culturally illegal, especially in the UK.
I know. No, absolutely. So I'm. It just gives us a little bit of time. I need to thank the patrons.
Yes.
And I'm going to thank them because they were really supportive on Discord. They've always been super Discord, always really, really nice to me. When I had a little bit of a break and they were super supportive, I cannot thank them enough for all that. It was stressing me out that I wasn't delivering a podcast, and they said, "Matt, don't be silly. You can have a little bit of time off." So I
they
felt
were completely right.
They were completely right. So thank you very much. And here is the list of the greatest people on Earth. First of all, to the mega legends that are Drew Wright and Justin Roberts, who are at the ace level and will return to being mentioned at the head of every single month's show. And then there are the Skylon Patreons, who are Adam French, Auden Vala, Ben Guthrie, Bob Hodges, Bob Moore, Gene Watchtanik, Jacob Economy, Jim King, Kenton Hokanson, Mark Huber, Mark Kelly, Mark Schern, Marissa Davis, Malta Keisling, Neil Hansen, Paul Hilton, Rob Unable, Ronald Hatcher, Seth Hybarlin, Steve Croucher, and Tristan Tupper Hyde and Tyrrell McAllister. Thank you so much, genuine legends. And thank you to all the other patrons out there, of which there's another 40 or so. Thank you so much for supporting the show. Lynn, thank you very much for joining me once again. What should we do next month?
Okay. Maybe
Give me a
people
topic.
can chime in. So I think something that we could talk about would be a specific category of exoplanets. Oh my God, Lynn said exoplanets again, but bear with me. It is a special one because there are a subtopic of exoplanets called not hot Jupiter, no, ultra hot Jupiters. And they're very special and very weird. And there's a lot of cool stuff that goes on with them.
What's the difference between an ultra hot Jupiter and a brown dwarf?
I don't know, kind of spoilers now. But
Oh, okay. Well, there we go. We got a teaser.
Yeah.
No, don't do it. It's a teaser.
I won't do it.
It's a teaser.
I won't do it.
We'll do it. We'll do ultra hot Jupiters next month. Ultra hot. There's going to be an ultra hot Jupiter section.
There you go.
I promise you that.
There we go. Topic lined up.
One topic lined up.
Yeah.
So there we go. Spoilers.
Spoilers.
What are you doing? What are you doing this month?
I'm being incredibly frustrated because fun fact about doing astronomy research is that sometimes you run a code twice in a row and it's supposed to do the same thing twice and then it doesn't. And you don't know why. And you spend 3 weeks pulling your hair out. So I've been wrestling with code as per usual.
Do you know what? I don't think I've ever written a piece of code where you don't sit there for hours going, I don't understand. Why is it not working? Why is that not working? Why isn't it working? And then it turns out to be a comma or you put something in the wrong place. You have to go away and have a cup of tea and then come back to it. And when I say a cup of tea, I mean like Indian black tea that's brewed correctly, not in a microwave. I
thought you were going to say like with whiskey in it or something.
No, definitely not. That's an abomination. You can put whiskey in coffee, but never in a tea.
No.
What the hell were you thinking?
I don't know. I've never done it. I promise.
You've enraged my cultural sensitivity.
So sorry. My supervisor actually today, I was complaining to him, and I think he was joking, but I'm not actually sure. He said sometimes the thing with code is that you just have to trust it. You have to have faith in it because it can sense if you're uncertain about it. And I was like, what? It's like a dog. It can smell fear. And he was like, yes, sometimes you have to trust it. I'm pretty sure he was kidding, but maybe he's right.
If the code gets big enough, it may become sentient.
And the next episode after Ultra Jupiter will be artificial intelligence.
That does sound like that sounds like George's crazy corner. Who knows what he's going to come up with?
There
next
you
month.
go. We'll delegate the
the crazy corner
to the crazy corner. So if that's the crazy corner, then what the hell is this?
This is just the podcast.
The very sophisticated.
The very, very sophisticated.
Very smart.
Two very smart adults talking to one another about nodding. I'm scratching my chin. I'm doing my chin.
I'm holding where I would have a beard if I had one.
Linn does have a beard. I just want to tell the listeners.
This is why I have a face for radio.
That really is ridiculous, right? Oh, well, there might be some exciting stuff going on this month, but I'll let you know via Twitter, so keep an eye on that, and we'll see you next month.
See you next month, everyone.
Bye.